So in this question, we have ammonium iron 3 citrate contain in its formula more than one ammonium ion. It contained one iron ion and it contained two citrate ions with a valency of a 4 minus. What is the formula of ammonium iron 3 citrate? Remember one thing, like you can work out a separate formula for ammonium and iron 3 citrate and then recombine, you will get the result. Or what is another way, because we have the options are given. As we know, it's a compound. What is the net oxidation number? Net charge on the compound should be zero. Like the net oxidation number, there should be no charge on the compound. If I give an example like copper sulfate. So when we talk about, like if I take a sulfate as an ion, sulfate charge is -2, the copper is +2, the net charge is 0. If I have sulfuric acid H2SO4, so sulfate is -2, each hydrogen is +1, so 2 will be +2, so the net charge is 0. So the idea is that whenever we add up the oxidation number or oxidation states of the molecular ions, the total, because it's a compound, so the total must be 0. So let's say if A was a right option, we have ammonium. We don't know A is a right or wrong, but let's say if A was a right. C6H4O7 and the charge total 2. So the charge on this one is -4. There are two of them, so this will be -8. Because one is -4, so 2 will be -8. What is the charge of ammonium ion, NH4 ion? You have to remember each is +1, so there are 4 of them, so this will be +4. And it is a iron 3, so iron 3 is +3. Is the total sum of the charges when I add, is it 0? The sum of the charges when I add. So it's not 0, means it cannot be A. When we check the second option, because the net charge should be 0. Now when we check the second option, there are 5 ammonium, 1 iron and 2 citrate ions. So each citrate is -4, so 2 will be -8. Iron is given +3 and 1 ammonium is +1, so 5 will be +5. So +5, so means the net charge is 0. If the net charge is 0, how do we combine? We just use the oxidation numbers. See, what we are doing, we are checking the options, which is because when the right formula, the net oxidation number, when we add the charges of each ion or the molecular ion, the net should be 0. So if A, when let's check with the option A, when we check with option A, if I check with option A, C6H4O7 and in a bracket 2. So each citrate ion is -4, so 2 will be -8. Each ammonium ion is +1, so 4 will be +4. And iron is +3. So this is +4, this is +3, and this is -8. The sum is not equal to 0. The sum is equals to -1, means this cannot be a formula for a compound. It will be an ion, but it cannot be a compound, because when we add the oxidation number, the net oxidation number should be 0 on the compound. When we check option B, NH4 is there, bracket 5, Fe, Fe is there, and then we have a citrate which is C6H4O7 with a charge, with a 2 ions are there. Each citrate is -4, so 2 will be -8. Iron is +3 according to a question, the Roman number. And ammonium, we know it's +1, so 5 of them should be +5. So +5 +3 makes +8, and +8 -8, the net will be 0. So means this will be a compound. Is it clear? How we combine the two formulas in the first method. After writing a formula for individual, you will take the simplest ratio, but it will take, it's an MCQ. That's why I just taught you a trick to work out the right formula. Because that is the method, that is the whole method in which you find the formula of a compound which contain two positive ions and one negative ion. Or it might have two negative ions and one positive ion. So best way to do such question, if you want to identify whether it's a right formula, you just add the oxidation number. If it's a compound, the net oxidation number should be 0. Silicon 4 oxide react with a chlorine and carbon to form a liquid silicon 4 chloride and a carbon dioxide. If the reaction is carried out at room temperature and pressure, which symbol equation represent this reaction? So silicon oxide at room temperature, what is the state of a silicon oxide? Because it's RTP, so at room temperature it is solid. So means
Okay.
it should be solid. What about the chlorine at room temperature? Chlorine is a gas. What about the carbon dioxide? Form a like carbon, I mean, not carbon dioxide. Carbon is a solid at room temperature. Form a liquid silicon 4 chloride. So liquid silicon 4 chloride. So this is a liquid silicon 4 chloride, and the carbon dioxide gas is there. So what is the mistake? Like here, what is the mistake? The state of silicon is not correct. Here, what is the mistake? In this one, the state of a silicon, they mention here it's forming a liquid, but it's written a gas. Is it clear? Any other question? Those who are having exam tomorrow, paper 2 or 4, if you have doubt, you can mention your doubt. I will answer that.